Hello everyone, welcome back to my series on how to create computers using Minecraft and digital logic. Now, last time, in case you forgot or didn't watch the last episode, we created some very vital gates. In specific, we made this here a NAND gate and this here a XOR gate. So today, instead of creating new things, I'm going to be explaining data and the plan for the next few episodes. So, data in a computer is stored using ones and zeros. You've probably heard that a lot. Now, let's say every single lamp that is on is a 1, and every lamp that is off is a 0. Right now, we are in what is called a 1-bit system, or one lamp. Now, the only problem is a 1-bit system can only display 1 or 0, which is cool, but not enough to actually store anything useful. So for the next few episodes, we are going to be making a 2-bit system. So instead of only having 1 and 0, we will be able to go from 0, 0 to 1, 1. So in this case, this would be 1, this would be 2. Now, for example, let's say both of them are on, or 1, 1. That would be 2 plus 1, or 3. Pretty simple. Now, once you add a third bit, you may be thinking, so that's probably 3, right? No, that is 4. So for example here, this would be 4 plus 2 plus 1, or 7. So the next one would be 8. Then it would be 16, and then, yeah. And if I were to do something like this, you would skip over the 2, so it would just be 4 plus 1, or 5. Now, we won't be getting into automated data yet. I'll just be saying that. But what we're going to be doing is creating what's called an adder, which is something that can take two 1-bit signals and turn them into a 2-bit signal, which is going to be very essential for later. Because I'm very sure you're going to want more than a 1-bit system. Especially considering you can't really do math with a 1-bit system. You either have a 1 or you don't. And if you don't, then you don't. You don't get a 1 out of 0. You can't add 0 plus 0 to make 1. And in order to do this, you're going to be needing 2 signals. A and B. Hold on. Now, here's where that gets a little bit more complicated. So while we have A here and we have B here, that's not actually going to be enough. Because the thing is, with adders, they are modular. You don't just have a 1-bit adder, which is what we're making. You want to have a 4-bit, which is made out of 4 1-bits. So you would make a third signal called carry. Now, the way this works is, let's say I have a little math problem here. I'm going to write this all in binary, so you have 1 here and 1 here. That's what our adder would be doing, is adding 2 different numbers. So we got a 1 here, 1 here. Now here's the thing. That can't be a 2. You can't have two redstone signals going to the same thing because it would just do the same as 1 bit. So instead, that would be 0. And then you would take a 1 and put it here. Now let's say there's 2 1s here. So that would be 1 plus 1, or 2, so you put that there. And then there's still 1 left over, so that would be a 1. Now let's say there's nothing in here. So that would be a 1. So now we have our answer, 1, 1, 0, or 6. Which we got by adding 3 plus 3. So essentially, this is going to be doing really basic math, which is very important to the computer. Now, adders are an important part of what is called a arithmetic logic unit, or a ALU, which is one of the key components of a CPU, one of the most important parts of a computer, if not the most important. So now that you know all that, I'll be doing an adder in the next few episodes, probably 1 episode, and then I'll make a 4-bit adder out of that, and then that's what we're going to be using to make our first ALU. Until next time, guys, stay frosty.